This is Chapter 9, Section 9.1, and in Chapter 9, we're going to be extending the methods learned in Chapter 7 and Chapter 8 that were involving population parameters and dealing with a sample from one population to now talking about two populations for Chapter 9. So we'll be starting in 9.1 talking about two proportions. So in this section, we're going to be testing a claim and constructing a confidence interval about the difference between two population proportions. So inferences about two population proportions. We're going to be hypothesis testing using the p-value and critical value method, and then confidence intervals as well. So we will be having a little bit of different notations here. Because we're dealing with two populations, we'll be talking about sub 1 and sub 2. And you may see information about the pooled sample proportion as well, p bar. So what we're talking about here is two samples that are independent. So samples are independent if the sample values selected from one population are not related to or naturally paired with the sample values from the other population, and that they're simple random, and that they abide by at least 5 successes and at least 5 failures. We'll be using the TI-84 for our hypothesis testing, and we'll be using this function here, the 2-prop-z test. And we'll need the x, the n, and the formatting for the alternative hypothesis. So we'll need the number of successes and the number of observations for both samples. So x1, n1, x2, n2. We'll be getting the p-values automatically by TI-84, and then the critical values we'll use spreadsheet technology just like we've been doing in the preceding chapters. So in this case, the null hypothesis is going to be when p1 equals p2. So basically the two population proportions are equal. We've seen this wording, we'll continue to use the same wording, and then let's get started. So use a 0.05 significance level in the p-value method to test the claim that Connecticut and New York have the same proportion of cars with rear license plates only. So the claim here is that Connecticut and New York have the same, so I'm going to say equal, rear licenses. Okay. So let's call Connecticut P1, and we'll call New York P2. So for our null hypothesis, that is actually our claim that the proportions are equal. And our alternative would be then that the proportions are not equal. So now we're going to just make sure here that Connecticut, this cars with rear license plate only, that's what we're talking about. That's our X1. And this is our N1. New York X1, N2. Okay, let's take out our calculator here. So for our calculator, we are going to, and I just want to make sure we can place this all in. We're going to go to tests. We're going to go to stat, tests, and we're doing the two proportion z test. And our X1 is 239. Our N1 is 2049. Our X2 is 9. Our N2 is 550. And if we go look at our alternative, we are not equal to. So we'll hit calculate. And we get the test statistic of 7.11, but we're going to look more at that p-value. So when we look the p-value of 1.19 e negative 12. That means it's 0.0000001.19. So that p-value is essentially 0.000. So how does that compare to our significance level? It is lower. So when the p is low, the null must go. We reject the null hypothesis. When the p is low, the null must go. So we reject the null hypothesis, which is actually our claim. So we would say, you can kind of go back to the wording here if you need to, our claim had equality and we rejected. So we would say there is sufficient evidence to warrant rejection of the claim that Connecticut and New York have the same proportion of cars with rear license plate only. And so essentially we're saying that if it's not the same proportion, that it must be different proportions of cars. So go ahead and give this one a try. And I just want to make a note here that they don't give you the total right away. In this problem, they give you the number of accurate and not accurate. So be super mindful that they're asking about accuracy claims. So those would be your successes would be accuracy. And then your N would be your total. So you're going to have to add those up. That's my warning for you for this one. Press play when you're ready to see the solution. And there you go. For example 2, we're going to use the critical value method. So we were talking about passenger cars in New York, but now we're going to consider cars and trucks. So among 2,049 Connecticut passenger cars, 230 only had rear license plates. Among 334 Connecticut trucks, 45 had rear license plate. A reasonable hypothesis is that passenger car owners violate license plate laws at a higher rate than owners of commercial trucks. So they're claiming that cars have more owners violate the license plate laws at a higher rate than trucks. So cars at a higher rate than trucks. So we'll make cars our P1 and P2. So our null is going to be P1 equals P2 always. That's not our claim. Our alternative hypothesis is our claim. So now let's just make sure we've got our Connecticut passengers. These are our cars, right? So this is our N1 and this is our X1. And this is our X2 and our N2. So we're going to go into stat tests and to proportion Z test. And our X1 was 239 and 2,049. That stayed the same from our previous example. This time our X2 is 45 because we're talking about trucks. And our N2 is 334, and now we want to know about greater than. So we're going to calculate this, and we end up getting our test statistic as Z equals negative 0.946. So now we're going to use our critical value. You might be like, oh, I see the p-value, I just want to reject or not reject, but we can see that this is a right-tailed test because of the greater than. The significance level is 0.05. So we want to get this Z value here. So we've got we're going to do norm in because we want that. So the probability here is 1 minus 0.05, right? Because that's the area to the left. The mean is 0 and 1. We get 1.645. And you may have these memorized at this point because the critical values don't change with the different significance values. So these are great to have on your cheat sheets as well. So now let's look at our test statistic. Our test statistic is all the way over here. Remember, that's 0. So here's our test statistic. So this is not in the critical region. This is a fail to reject the null hypothesis. So again, this is a fail to reject the null hypothesis. So essentially meaning, right, there is not sufficient evidence to support the claim. So fail to reject, you can kind of think of that almost as like an accept. It's not really, but that's saying like we kind of accept the null. That wasn't our claim. So there is not sufficient evidence to support the claim. And here is the full sentence. Go ahead and give this one a try. Press play when you're ready to see the solution. You can use either the p-value or critical value method. I showed the work for both. And that's the solution. For part 2, we'll be doing the confidence interval estimate, and that concludes 9.1 part 1.